I've been actually talking about integration most of the way through the previous exercise because, as I've been saying, what you will now be asked to integrate that will result in a primitive function that is an inverse trig function doesn't have anything to do with trig in it. So we know it's a fraction, so you're asked to integrate yet again another type of fraction. What do these fractions look like? Well, hopefully you really paid attention to your derivative answers, and there is the indicator of what you could be, the type of fraction that you could be asked to integrate. So we know that they look in some ways familiar to, we might be asked to integrate 1 over the square root of some constant squared minus an x squared. And keep in mind that a could be simply a 1, like here in the next one. But there's a negative at the front, so we know that goes to cos inverse. And then finally the tan inverse was again a fraction, x squared in the denominator. This time it's got a plus, and this time there is no square root. I guess in terms of the easiest and obvious ones will be the sine inverse and cos inverse, because they've got the square root of negative x squared. And like I said before in a previous video, you might be tempted to think about this one as a log. However, hopefully you can see there's no derivative of the x squared in the numerator there, which you would need if it was if its primitive function was the log function. So apart from knowing that, then just be familiar that the two integrals are on the reference sheet, and really what you're learning, predominantly what you're learning in this exercise, is to recognise the fraction. Recognise the fraction. Now, that will be so much easier for you if you did focus a lot on the answer that you got to your derivative and connected the two. After differentiating, I get this particular fraction. What does that mean in terms of integrating? It means I get this sine inverse, or cos inverse, or tan inverse. So, some points to note, and I've covered this one as well too previously. The integral that results in a cos inverse doesn't appear on the sheet, so you've got to know that it's just the negative of the sine inverse. So maybe some of you might add this, that the integral of negative 1 over the square root a squared minus x squared dx is cos inverse. No negative, just straight out cos inverse. Learn the connection between the derivatives and the integrals. Well, we've been doing that. We've been focusing on that. The inverse trig functions are required for integration of some algebraic fractions as well. And the integrals can be compared, and I talked about this in a previous video, with when we were integrating 1 on x. And again, that's one where you just have to know that the integral of 1 on x goes back to, or has as primitive function, the log function. Okay, let's have a look at some examples. Oh, just one thing before we look at some examples. Think about the applications here. We know the application of integration is to find the area or the volume of a solid. So if we have the integral of a 1 over, for example, 1 over square root 1 minus x squared, we would need to know what that graph actually looks like, because we're finding the area under the curve. So it's, as it says here, it's you really will need a very good understanding of the graphs of these three situations. So the positive, 1 over square root 1 minus x squared, and here we've got a fairly restricted domain because we can't take this square root of a negative number. So once x is outside minus 1 and plus 1, well, we can't even have minus 1 and plus 1 because then we've got a 0 in the denominator. Square root of 0 is 0, but we can't have a 0 in the denominator. So we have to think about all those things. So they're fairly restricted sorts of graphs. And 1 over 1 plus x squared, just becomes that. It's never a fraction bigger than, or y is never a number bigger than 1, because we just keep adding on to the size of the denominator, which makes the overall number a smaller and smaller fraction. Yeah, just like I said, be familiar with those sketches. And always have your calculator set to radians if you're actually evaluating an area or a volume. So with the first question, what do you see? We're integrating x in the denominator of a fraction. How do we know it's not a log, not going back to, or its primitive function not being log? It's because we've got an x squared here and there's no sign of a 2x or even an x in the numerator. It's very much 1 over a squared. 16 is a perfect square. That's another thing to really note here. 16 is a perfect square. So it is in the format 1 over 4 squared plus x squared dx, could sit on the end. And hopefully you won't do any of these without your reference sheet beside you, and in an assessment task in the HSC exam you will refer to your reference sheet all the time. So because you do see it when you're marking HSC, where students haven't paid close attention to the reference sheet, or they don't know what's on it, or they're just not careful in transcribing what is on the reference sheet onto their answers, which is just throwing away marks. And that, you don't you don't need to do that. In fact, you're trying hard not to give away marks, trying to get every mark that you can. So in this case, I think we could see that it very nicely matches the format on the reference sheet. And you can see there that our 1 on A becomes 1 on 4, 10 inverse x on 4 plus the constant. Now, in example 2, we're taking the integral of -1, and we can clearly see the square root. So that's shouting out, hopefully, sine inverse and cos inverse. And to me, the negative there is saying cos inverse. However, you wouldn't be wrong if you took the negative 1 outside and took the integral of 1 over this, and you would have negative sine inverse. Both answers are correct. I think because it's got the negative, we'll go with the cos. So we've got our integral, negative, this format goes to cos inverse x on A. When we take a closer look, we've got 3 as A squared. That means A is root 3. Just be careful of that. A, in this case, is root 3. But then we just sub that in as cos inverse x on root 3 plus the constant.